Okay, we're in the last unit of our trig that we're doing for a couple quarters. So what we're going to do is talk about what we went over today. So what we talked about today mainly is this idea of the angle of depression, angle of elevation. So what you want to think about it is like when we have two individuals, like one on top of the hill, one down at the bottom, the person looking up has an angle of elevation. The person looking down has an angle of depression. What we're going to find out is that they both make right triangles. So the person looking up, the angle of elevation, there's my right triangle. The person looking down, elevation, I'm looking down, angle of depression has kind of the upside down. So this is our idea. We're dealing with these right triangles. And depending upon how the problem is worded, we are going to either be looking for a missing side, looking for a missing angle. So I'm going to do a couple examples just so we have a little bit of a review of what we did in class. So what we did is problems like this. So let me kind of zoom in so we look a little bit better. The angle of depression is measured from the top of a 43-foot tower to a reference point on the ground. Its value is found to be 63 degrees. How far is the base of the tower from the point on the ground? So in this case, we're given up here. This is my angle of depression. And what I want to think about is I don't want to look over here at this triangle on the right. I actually want to kind of envision this triangle over here on the left. And if we think about it, this 43 feet high means it's 43 feet over here. The length of x is x. So here's the deal. I have an angle. I have two sides. So what I'm going to do is I'm going to kind of get my idea from this angle. 63, this is my opposite. 63, this is my adjacent. The trig function that deals with opposite and adjacent is tan. So I take the tangent of 63 degrees, and that's going to equal my opposite over my adjacent. So my tangent of 63 degrees is going to equal 43 over x. And now what I'm going to do is I'm going to solve for x. And the way I said in class to do this is consider it like a cross multiplication. So 1 times 43 gives me 43. And then I do x times tangent of 63. I get x tangent 63. I want to free the x, so I divide each side by tangent 63. And then I pick up my calculator. And when I do my calculator, the first thing I want to do is I want to make sure in mode that I'm in degrees. So I do mode and I make sure I'm in degrees. And now what I'm going to do is I'm going to go right to the calculator. I'm going to do 43 divided by tan of 63. I hit enter. And that's 21.910. That tells me that x, that distance there is 21.910 feet. And what I said is we typically are going to go to 3 decimal points on sides, and we're going to go to 1 decimal point on angles. So in this case, what we got here is we have an example of looking at a figure, figuring out what they gave us, solve for that missing piece. I'll do number 2. Number 2 says the angle of depression from a searchlight. So again, we're looking at this one up in the top left is 58 degrees. How long is the beam of light if the searchlight is 26 feet above the ground? So again, let's make ourselves that triangle. There's my right triangle upside down. I'm going to put 26 over here because if it's 26 tall here, it's 26 tall here, our rectangle. And what we have here, again, is we have opposite, but in this case, we're looking for the hypotenuse. And if we do opposite and hypotenuse, that's sine. So sine of 58 degrees is going to equal opposite over hypotenuse. So sine of 58 degrees is going to be opposite 26 over x. I'm going to go through that same process, cross multiplication. I'm going to get x sine 58 degrees equals 26. Divide both sides by sine 58. Sine 58. And what I'm going to do is go to my calculator, and I'm going to do 26 divided by sine of 58 degrees. And it's 30.659. So the hypotenuse there is 30.659 feet. So that's, again, one with tangent, one with sine. So I'm going to jump around a little bit and make sure we get all of them. So in this case, what we're dealing with, which one do I want to deal with? This one. Let's do this one down here. Number 5. A closed circuit television is mounted on a wall 7.4 feet above a security desk in an office building. It is used to view an entrance door 9.3 feet from the desk. Find the angle of depression. So what it wants me to do is it wants me to find this angle here. I don't know that angle, so we're going to call it theta. And again, because it's an angle of depression, I'm going to kind of bounce over here. There's my right angle. This side is going to be 7.4. This side's going to be 9.3. And what I notice here is I have my opposite and I have my adjacent. So I'm dealing with tangent again. So in this case, tangent of this angle I don't know is my opposite 7.4 over my adjacent 9.3. And this is different because I'm given two sides. And since I'm given two sides, what I'm going to do is I'm going to use the inverse functions. We talked about when I do this, the arctan of tangent, those basically cancel out, leave me with just the theta. But in the world of math, if I do something to one side, I got to do it to the other. 7.4 over 9.3. If we look right here on the calculator, tangent -1 is in blue. So we're going to hit the blue second. We're going to hit the tangent, that gives us the arctan. And we're going to do 7.4 divided by 9.5. And that's going to give me 37.9 degrees. That tells me that the angle of depression here is 37.9 degrees. So this angle, this camera points down at about a 37.9 degree angle. So if I'm given two sides, I'm going to use the inverse function. So that's the difference. So again, up here, I was given an angle on a side. I solved for a side I didn't know. Down here, I'm given two sides, and I'm looking for an angle that I don't know. Okay, the only other one I want to do is just so you have it as an example. We talked about this. This was like kind of our special case. This one right here is kind of different. It says we have an extension ladder on top of a 6-foot high hook and ladder truck is 150 feet long. So that ladder is 150 feet long. The ladder can go to a 70-degree angle. And what I want to figure out is how high up can that ladder go? So if you think about it, I can work on this triangle here, this right triangle here. I have 70 degrees. I have opposite. I have hypotenuse. So I can do sine of 70 degrees equals opposite x over hypotenuse 150. And now what I can do is I can solve for x. In this case, I'm going to multiply both sides by 150. And I'm going to do 150 times sine of 70. And that's 140.954. That tells me that that ladder reaches up 140.94 feet from the truck. But then I'm going to add that additional 6 feet of being lifted up by the truck. So it's going to be 146.94 feet. So that's the big one. And it's about adding it at the end. How we talked about it in class and how you need to be aware of it is like this. This is the big one that I need to kind of keep in mind, is that when I end up with, say I have someone looking at a building. Okay, so what I do is I have a person, that person is looking at a building. And I'm going to tell you that that person is, let's say they're 70 feet away from the building. If I tell you that their angle of elevation to look at the top of the building is, so again, if I told you that their angle of elevation to look at the building is 42 degrees, it's not 42 degrees from their feet, it is 42 degrees from their eye line. So what that is saying is that realistically, I'm dealing with a 42-degree angle here. There's my right angle. And this length here is going to be 70 feet, because if your feet are 70 feet from the wall, your eyes are 70 feet from the wall. And now here comes the deal. I need to know how high your eyes are off the ground. So let's say that your eyes are 5 feet off the ground. So now what I can do is I can actually figure out the height of this part of the building. I can figure out how tall that part of the building is, and then I'm going to add the 5 feet to it. So I'm going to go through the same process. I need to know this, that's opposite, that's adjacent. I'm going to say tangent of 42 degrees equals opposite x over adjacent 70. Grab my calculator. That's going to be tangent of 42 times 70. So that's going to tell me that the building from my eye line is 63.028 feet tall. But I need to add that extra 5 feet at the end. So this building is really 68.028 feet tall. because of the 5 feet from my eye line. So that's kind of our special case. Just keep track of that because it does pop up from time to time. So that is what we talked about today. We're going to jump into law of signs on Tuesday's class.